All right, so chapter 3 is all about analyzing our quadratics in factored form. So chapter 2 was all about learning how to factor. So we would take a quadratic in standard form and we'd practice factoring them. So now that we have them factored, they look like a form like this. Okay, we have some coefficient out front, and then we might have, say, example here, -3 times, that was like the greatest common factor that we would have pulled out when factoring. And then we have our x minus 3 and x plus 1. So for the ones that we're going to do, we are just going to be looking at cases where x is on its own inside of the bracket. There's no separate coefficient attached to it. Okay, so this is called factored form. And what I'm going to start off by doing is sort of comparing what information we can get from standard form and what information we can easily get from factored form. So basically, why do we use factored form? All right, so vertex. So if we're looking at the vertex, well, on a graph, really easy to say, oh, there's the vertex. So you might be able to locate it on a graph. In this case, 1 and 12. So you can say 1 and 12. However, finding the vertex from the equation, not so easy. In fact, if you were to do it, the best thing would be to actually complete the square, change it into vertex form, and then you have the vertex. That's something we'll be doing in chapter 4. But directly from the equation, don't know. Hard to do. Okay. Now if we look at factored form, again from the graph obviously looks the same because it's the same function, right? This factored gives us this. Okay, so looking at the graph, well, our vertex is 1 and 12. But how can we find that out from the equation? Well, obviously the vertex is easiest to figure out in vertex form, which we've done a little bit in chapter 1, we'll do more in chapter 4. But there is a way of doing it with factored form that's certainly easier than trying to figure out in vertex form. And so what we do is we sort of split this quadratic, this parabola, in half. This is called the axis of symmetry. It's called the axis of symmetry because if I cover this portion, you can see it's a mirror of the other side. Okay, and that axis of symmetry is fairly easy to locate. And this is how we do it. Okay, let me just go down and say the X-Intercepts. Now to be able to find the vertex, we need to know the X-Intercepts. And the X-Intercepts are very, very easy to locate in factored form. Right now on our graph, they're here and they're here. Okay, now to figure out what those points are from an equation, what you would do is you would set y equal to 0. Okay, if y equals 0, right, then you can solve your equation for your x-axis. Well, looking at this equation, if y is 0, so let me just write, if we set y equal to 0, then that means for this right side of the equation, 2 equals 0, you have two options. Option 1, if this bracket is 0, then this times whatever these are will be 0. Or option 2, if this bracket is 0. Okay, well, let's look at option 1. How can we make x minus 3 equal 0? So if x minus 3 is equal to 0, rearranging that equation, if we set x equal to 3, 3 minus 3 equals 0. So x being at 3 is one intercept right there. Well, what about our other option? X plus 1. That's another option. If x plus 1 equals 0, then this entire right side of the equation will equal 0. For this to equal 0, x must be equal to negative 1. And that's our other x-intercept right here. Okay, so those are our points 3 and 0, and negative 1 and 0. So you can get those values just by a quick glance, right? You simply look at what, say, R is and what S is. So you look at the bracket and you take the opposite sign. The opposite of -3 is +3. There's one intercept. The opposite of +1 is -1. There's the other intercept. Let me just pause there to see how everybody's doing. All right, so now that we know where our X-intercepts is, we can figure out where this axis of symmetry is, this line here, because it's going to be directly in between them. So to find a point directly in between 2 points, we simply essentially take the average. And so you have -1, I'm going to squeeze that in here, so -1 plus 3 and divide by 2, so there's your average. -1 plus 3 is 2, divide by 2, and that's just 1. So this is at the coordinate x equals 1. And that is where our vertex is going to be. So our vertex will be at the x-coordinate 1. Then you just need to figure out what the actual y-coordinate is. Alright, so now that we have the x-coordinate for our vertex, to find out what that y-coordinate is, what we need to do is actually take that x value and substitute it into our equation. So I'm just going to do that up here. So I'm going to write y equals, and here's -3, times by x minus 3, but I'm going to write our x-coordinate for the vertex, that's 1, multiplied by x plus 1, but again I'm going to write the x-coordinate, which is 1. So we get -3 times -2 times +2, which gives us 12. Alright, so here we have the points 1 and our y, 12. So obviously a lot easier to find the vertex using vertex form, but still doable with a couple of steps from factored form. Whereas trying to do it from standard form, I mean, my go-to would be to change that into vertex form. Okay, so let's compare a couple of other things. The direction of opening. Well, I mean, from the graph, you can easily see that it opens down. Okay, so opens down. And the graph doesn't really care what equation you used or what form of that equation you used to graph it. It looks the same. Opens down. Can you easily see that from the equation? The answer is yes, in both cases. Okay. Here, you look at your A coefficient, which is -3. So I say A equals -3, and because it's negative, I know it opens down. And I can do the same thing here. We still have that same A coefficient here. A equals -3. And again, because it's negative, it opens down. So just as easy to figure out whether or not the graph opens up or down from either equation. Now the x-intercepts we already saw using factored form, or otherwise known as intercept form, very easy. You can just pick it out at a glance. And from here, not so easy. In fact, if I was given an equation like this and asked to find the intercept, I would factor it. And essentially I'm putting it into factored form. So no, not so easy to do it with standard form. Okay, last thing, the y-intercept. Well, to find the y-intercept, you set x equal to 0. Now essentially you can do this a little bit easier with standard form. Because if x is 0, that whole term disappears, this whole term disappears, and you're just left with your c coefficient. So you can do that at a glance using standard form. So standard form, you can easily say the x-intercept is 0 and, the y-intercept is 0 and 9. Now you can still do it with factored form. Right? It just takes an extra step, but if you're setting x equal to 0, right, again, we look at our equation, we would say y equals -3 times 0 minus 3, which is just -3, times 0 plus 1, which is just 1. And so these two multiplied together give you 9, times 1 gives you 9. So your y-intercept is 0 and 9. And so here are the differences and where some of the advantages of factored form can actually come in for us. Just pause that, see if you haven't. Alright, so before we move on and practice with just factored form, I want to go over a few terminologies. One is the zeros. So if I ever ask you to find the zeros, what I'm actually talking about are those x-intercepts. Right? Which, again, you can grab those x-intercepts from intercept form or factored form just at a glance there. Okay, the axis of symmetry, right? That's that line which basically mirror images your graph from one side to the other side. Our axis of symmetry, in this case doing quadratics, will always be a vertical line. Okay, it is possible to have your axis of symmetry as a horizontal line, but we won't be doing those. Okay, then we have the maximum value. That would be the largest possible value or the minimum value. So what do I mean by maximum and minimum? It does depend on whether or not your quadratic opens up or opens down. Right? If it opens down, right, that keeps going down forever. Right? So you don't really have a minimum value, but you do have a maximum value right there. And so you will have a maximum value if your quadratic opens down. However, if your quadratic opens up, okay, it's going to go up forever. So you're not going to really have some maximum value, but you will have a minimum value right down here. And those are your vertex. Okay, so your vertex on a parabola that opens down tells you what that maximum value is, and the vertex for a parabola that opens up tells you what that minimum value is. And you're only ever going to have one or the other, not both. Okay. So let's practice. We're going to start with this first one. So here we have an equation already in factored form. Okay, now we can go back and forth between factored and standard. If we have standard, we factor it. If we have factored form, we expand and simplify. Okay, so to expand this one, let's leave the 2 on the outside first. And on the inside, we're just going to use our distributive property or just FOIL. So x times x gives us x squared. X times -3, minus 3x. And then 1 times x, which is just x. And 1 times -3, which is -3. Okay, you're going to collect like terms. So you'll have 2 times x squared minus 3x plus x, it's just minus 2x, and then minus 3. Now we can actually do something with that 2. So we're going to distribute that 2 into every term in the bracket to give us 2x squared minus 4x minus 6. So that is what it looks like in standard form. Now using factored form, we can get the zeros or the x-intercepts. Right, so just looking at this bracket, right, again, take the opposite sign, -1. So one x-intercept is at -1 and 0. And our other x-intercept, take the opposite sign. Right? -3, opposite sign would be +3, is going to be at 3 and 0. Alright, so those are our 2 x-intercepts. Now, to find the vertex, this is probably the step that takes the most steps. You're going to find the average of those x-intercepts first to figure out where your axis of symmetry is. So let me actually do this column first. I should have put that one first. Let's take the average, so minus 1 plus 3 divided by 2. Okay, so that's 2 over 2, which is just 1. So our axis of symmetry is at x equals 1. And that is our x-coordinate of our vertex. All we have to do is figure out what that y-coordinate is. Now to do that, we're going to take 1 and substitute it back into our function here for x. So we have 2 times x plus 1, where x is 1, so 1 plus 1 is 2. And then x minus 3, or substituting 1 for x, 1 minus 3 gives us negative 2. 2 times 2 is 4, times negative 2 is negative 8. So our vertex is then at 1 and negative 8. To find the y-intercepts, okay, on any graph, your function goes through your y-axis at the value x is 0. So now we're just going to sub 0 back into this equation. So we have 2 times 0 plus 1 is just 1, times 0 minus 3 is just negative 3. And we get 2 times 1 times negative 3 is negative 6. So our y-intercept is at 0 and negative 6. And lastly, to find the minimum or maximum value, well, first we need to know whether or not it is a minimum or it is a maximum. That value is our vertex, but which one is it? Okay, so to determine that, remember from up here, we need to see if it opens up or if it opens down. So let's look at our a value. Our a value is positive 2. If it's positive, that means that it opens up. Okay? And if it opens up like this, that means we have a minimum value. And that value is your y-coordinate of your vertex. Okay, so your minimum value is y equals negative 8. Which again will help us later when I ask you for things like range. When I say like find the domain, find the range, right? Your range is for your y-coordinates. So in this case, y being negative 8 is our minimum value, so our function has a range of y being greater than or equal to negative 8. Okay, I'm going to pause. Now for the next problem, to be able to do all this, we need factored form for our equation. We only have standard form, so what we need to do is factor. Okay, now our a value is already 1. So you can think of it as 1 times 2 brackets, but again, we don't usually put the 1. So if you just see an equation with 2 brackets, just remember that a has a value of 1 in that case. So looking at this, what we need are 2 numbers that multiply to give us negative 10 and add to give us 2. Actually, that doesn't work. Let me change that to 3. There we go. That works. So 2 numbers that add to give us negative 10. Multiply to give us negative 10 and add to give us 3. So in this case, we can use 5 and negative 2. So there's what this looks like in factored form. And I'm going to give you a chance to try this on your own. I'll pause it.